Welcome to a lesson on multiplying binomials with radicals. We now know how to multiply
We
radicals
multiply
with the
the
same
factors
index.
outside the radicals together.
In this case, we'd have p times q. Then multiply the radicands together, which would be the terms underneath the radicals. In this case, we'd have u times v. And then we try to simplify the result. When multiplying binomials with radicals, we follow the same rules for other products involving binomial expressions. Meaning if we have a monomial times a binomial, in this form here, we'll have two products. We'll distribute and have a times b plus a times c. And if we have a binomial times a binomial, we'll have four products. Or we can think of this as double distribution. We distribute the a, so we'd have a times c plus a times d. And then we distribute the b, we'd have b times c plus b times d. Let's take a look at some examples. So here we'd have two products. We'd have square root 6 times square root 15 minus square root 6 times square root 2. So in this case, we'll multiply the radicands together. So we'd have the square root of 6 times 15. Notice how both of these terms are underneath the square root. And then we'd have minus the square root of 6 times 2. So this is the product, but now we want to simplify this. So to simplify this, we want to write the radicands in prime factored form so we can find the perfect square factors of this product and this product. Well, the prime factorization of 6 is 2 times 3, and the prime factorization of 15 is 3 times 5. So this is the prime factorization of this product, and then we have minus the square root of, well, 6 times 2 is 12, so the prime factorization is 2 times 2 times 3. And now we'll circle groups of two equal factors to find our perfect square factors. Here's 3 squared, and here's 2 squared, which are the perfect square factors. So the circled part will simplify. The square root of 3 squared is 3, so this simplifies to 3 square root 2 times 5 is 10, minus the square root of 2 squared is 2, and we have the square root of 3. This would be our simplified product. Next, we have 2 cube root 9 times the quantity 3 plus cube root 15. So again, we'll have two products, one here and one here. For this first product, we multiply 2 and 3. Well, 2 times 3 is 6. So this would be 6 times the cube root of 9. Notice we don't multiply the 9 by the 2 and the 3 because the 9 is underneath the radical and the 2 and 3 are not. And then we have plus, if it's helpful, we can think of this as 1 cube root 15. So 2 times 1 is 2. And then we'd have the cube root of 9 times 15. And now we want to simplify the cube roots if possible. So we'd have 6 times the cube root of, well, 9 is equal to 3 times 3, so we can tell this is not going to simplify because we don't have three equal factors or a perfect cube factor, plus 2 times the cube root of, well, 9 is equal to 3 times 3, and 15 is equal to 3 times 5. Notice here we do have a perfect cube factor of 3 cubed. So we have 6 times the cube root of 9 plus, here the cube root of 3 cubed is 3, so we have 2 times 3 times the cube root of 5. So this is 6 cube root 9 plus 6 cube root 5. Remember, we can't combine these radicals because they're not
the
like
radical part
radicals.
is not the same.
Now let's take a look at two examples of a binomial times a binomial. So here we'll have four products, 1, 2, 3, and 4. So we have the square root of 2 times 6. Again, notice how both the 2 and the 6 are underneath the square root, minus the square root of 2 times 10. And then we have plus the square root of 15 times 6. And then we have minus the square root of 15 times 10. And now we'll find the prime factorization of the radicands to help us simplify. So here we'd have the prime factorization of 6 is 2 times 3, so we'd have 2 times 2 times 3 minus the square root of 2 times the prime factorization of 10 is 2 times 5 plus square root of the prime factorization of 15 is 3 times 5 and 6 is 2 times 3, so we'd have 2 times 3 times 3 times 5 minus the square root of, again, 15 is 3 times 5, 10 is 2 times 5, so we'd have 2 times 3 times 5 times 5. And now we can easily identify the perfect square factors. Here's 2 squared, 2 squared, 3 squared, and 5 squared. So simplifying, here we'd have 2 square root 3. Since the square root of 2 squared is 2, here we'd have minus 2 square root 5 plus the square root of 3 squared is 3, so we have 3 square root 10 minus here we'd have 5 square root 6. We have no like radicals, so this is our simplified product. Now for the last example, there's no shortcuts here. We'll have to expand this. This is equivalent to 3 square root 2 minus square root 5 times the quantity 3 square root 2 minus square root 5. We cannot just square the first term and square the second term. Again, we'll have 4 products, 1, 2, 3, and 4. So for this first product, we have 3 times 3 is 9. So we have 9 times the square root of 2 times 2. And then we have minus. If it's helpful, we can think of this as minus 1 square root 5 as well as here. So we'd have minus 3 times the square root of 2 times 5. And then we'd have minus 3 times the square root of 5 times 2. And then finally we have negative 1 times negative 1, that's positive 1, so plus 1 times the square root of 5 times 5. Of course, this 1 is optional. Notice this will simplify. 2 squared is a perfect square factor, and so is 5 squared. Well, here the square root of 2 squared is 2, so we'd have 9 times 2 or 18. Here we have minus 3 square root 10. This doesn't simplify. Here we have minus 3 square root 10 again. And then here, square root of 5 squared is just 5. So combining like terms, 18 plus 5 is 23. Since negative like 3 radicals, minus 3 equals negative 6, we'd have minus 6 square root 10. I hope you found this helpful.